Hello, good morning students. Welcome back to our chemistry class. So in the last video lecture that is be completed your classes will be completed your unit organic chemistry section. Okay. So today will be continue with the new unit of this section, that is your state of matter. Okay. So all you know that how many states of matter. Okay. So under this unit will be study about related to your gases. Okay. Gases and liquid state. Okay, this is the two main things in this discuss in this unit. So students, let me start this unit. So students, firstly we started with the introductory part of this unit, that is all you know about state of matter, that is categorized mainly is your three you will study in classes. Okay, that is solid, liquid and gases, and after fourth and fifth state that is your plasma, and fifth one is your supercooled solid state. Okay, these are the five state, but that is we discuss about only three, that is solid, liquid and gases. So all you know about that is solid, they have the definite shape and definite volume. Liquids have a definite volume but not a definite shape. They can take a shape when we place in your any vessel. Okay, and third is your gases. So that state of matter neither a definite shape or not a definite volume, that is a three state of matter: solid, liquid and gases. Okay, so here that is fourth one is your, that is plasma state. Plasma state is generally that is mainly consist of a positive and negatively charged. In the plasma state they have present your particle like your positive and negatively charged ion, and this ion, positive and negatively charged ion, is formed by due to the superheating of a gaseous state. Okay, here the superheating of gaseous state. So here be the present of positively and negatively charged particle ions. Okay, and fifth one that is your supercooled solid state. So supercooled solid state is formed due to the loss of individually identity. Okay, that means ki here atom is lose its identity and its that is converted into its a single super atom, that we called as a supercooled solid state. This is about your state of matter. Okay, so students, first topic is your in this unit, that is your intermolecular forces. So intermolecular forces, they have the different forces. Firstly we um, started your general introductory part this topic, that is intermolecular forces. The force of attraction or repulsion exists among the particle. These type of forces, intermolecular forces, the force of attraction, that is your among the particles like your atom and molecules of a substance. Okay, and the electrostatic forces, that is other the electrostatic forces exist among the oppositely charged ions, and forces are hold together the atom molecules, that we is under your intermolecular forces, and example is your covalent bond. Okay, after that these intermolecular forces have a very high boiling points. Okay, and intermolecular forces, they have the different type of interaction, that is dipole dipole, ion induced dipole, dipole induced dipole interaction. Okay, dispersion force and hydrogen bonding, these are the intermolecular attractive forces arising. Okay, so here attractive intermolecular forces, that is your included dipole dipole, attractive intermolecular forces including dipole dipole. Okay, dipole induced dipole and dispersion forces, these are the three forces collectively we called as a van der Waal forces. Okay, so remember that the under van der Waal forces, which that is your dipole dipole, dipole induced dipole, and third is your dispersion force. They are be collectively called as a van der Waal forces. Sometime we used in some article, that is van der Waal forces. So remember that they have the three type of van der Waal forces, that is dipole dipole, dipole induced dipole, and dispersion force. Okay, next is your, so here the different type of intermolecular forces, that is be explained in briefly about the different interaction. First one is your dipole dipole interaction. So this force of attraction among the polar molecules, that means कि dipole dipole interaction is generally arises in the polar molecules, and you all know that what's the polar molecules. Okay, so reason that origin of these forces in this, that is a permanent dipoles present in your polar molecules, positive and negative. So the positive poles of one molecule is attracted by the negative pole of the other molecules, because polar molecules acquire the positive and negative poles. Okay, so positive pole is attract to the negative, the other molecules. For example is a HCl, because chlorine is the electronegative and that is acquire the slightly negative charge, and this is attract towards the hydrogen because hydrogen is acquire the plus positive charge. Okay, so here the magnitude of this dipole forces off in different molecules. Means say that ki not every molecule show the same strength of the magnitude of dipole interaction. Every molecule is differ the dipole interaction. Okay, and these dipole interaction that is predicted on the basis of polarity. Okay, and polarity means say that ki that is depend upon the electronegativity value of the atoms. More electronegative element, that means ki more polarity of the molecules and they have the more magnitude of dipole interaction. But in some cases they have the in atomic molecules, that means ki contain more two atoms in a molecule, just water molecules, phosphine, hydrogen sulfide. These are the examples of a polyatomic molecules. Okay, so in that case they can be expressed in terms of dipole moment of the molecules, and you all have learned in the dipole moment in the fourth chapter. Okay, that we represent as in this like arrows. Okay, positive. Okay, and this, that is tail is present here positive sign, and that is hook side here electron attraction. Okay, next that is interaction ion dipole interaction. So students, next that is category ion dipole interaction. So under this ion dipole, that means ki one thing, that is your one is ion, and second dipole, that means your polar molecules is your present. So this is attraction between an ion. Ion is your cation and anion. Okay, and polar molecules. So this is ion dipole interaction. Ion dipole interaction, here example is your NaCl is dissolved in water. So all you know that water is the polar molecules and NaCl is dissolved in waters to be induced, that is your ion, Na positive and Cl negative. So here the polar molecules of water, that is attract towards the positive, and the positive of hydrogen, that is attract towards the negative ions of chloride. Okay, this process is called hydration, and strength of this interaction of between the ions, that is depend upon the charge and size of the ion and the magnitude of the dipole moment and size of the polar molecules. Okay, next is your ion induced dipole interaction. Next is your third, that is your interaction ion induced dipole interaction. Ion induced, that means is also present is a positive and negative, and induced, that is a non-polar molecules. So a non-polar molecules may be polarized by the presence of ion near it, that is it becomes an induced dipole. The interaction between them are called ion induced dipole interaction. The interaction between ion induced is called dipole induced dipole interaction, and strength of this interaction, that is depend upon the charge present on the ion and in which the non-polar molecules, that is your be get polarized. So this is your non-polar molecules and this is your ions, because that is here partially positive and negative, but this is a same same that is same atom is present in one molecules, that is where non-polar molecules. Okay, so here cations, that is polarized by the attraction of the electron clouds, and where the anion is its maybe repulsion. So here example is a nitrate ion and iodine molecules, that is a non-polar. Okay, next is your fourth, that is your dipole induced dipole interaction. Dipole induced dipole interaction means that dipole is a polar molecules and induced dipole, that is a non-polar molecules. A non-polar molecules may be polarized by the presence of polar molecules near it, they making induced dipole. The interaction between them is called dipole induced dipole interaction. and the strength will be depend upon the strength of dipole. So for example, there is novel gases and that get be polarized by the presence of the polar molecules. So you can see that here the negative charge of this novel gases atom be attracted towards the positive charge of the polar molecules. Okay, and the existence of these type forces in a study by these forces induced dipole interaction by the Dewey in 1920, and this effect is called induction effect. Okay students, so this is about the dipole induced dipole interaction. So students, next is your fifth, that is your London forces or dispersion forces. So these type is forces we taught to arises the motion of electron, means London forces or dispersion forces is arised due to the motion of electron, because this motion of electron for instant of time, the electron clouds of the, okay students, so these forces be to arise due to the motion of electrons, and this motion of electron to be for instant of time the electron cloud of the molecules. So students, little bit for instant of time the motion of electron of the molecules may be distorted for instantaneous dipole, that is a momentary dipole. We called instantaneous dipole for a, we called as a momentary dipoles is produced in which one part of the molecules. So this is your atom that is symmetrical, and so students, for sometimes that is the motion of electron by the molecules that is distorted for instantaneous dipole. They produce the instantaneous dipole. This is your instantaneous dipole. Okay, and that is produced the one part of the molecule is slightly more negative. This is slightly one for more negative one part of this atom, and rest of the positive. Okay, so dipole induced dipole of the neighboring. Similarly for the neighboring molecules, and these then attracted to each other exactly in the same way, and the permanent dipole. So this force of attraction between the induced momentary dipole is called London dispersion forces. Okay students, so this is about your London forces. Next is your, that is a magnitude of London forces. So London forces are the weakest intermolecular forces. Remember that London forces are the weakest intermolecular forces, and the magnitude of these forces that it depend upon the two factor. First one is your size, your complexity of the molecules, and second one is your geometry of the molecules. So under the size, your complexity of the molecules, say that greater the complex, ये greater the complex are the molecules, जितना भी ये more complex molecules, greater is the magnitude of London forces. You can be understand by the, for example, for making the hydrides of group 14. Group 14 is your carbon, selenium and germanium. That is hydrides की, that is connected with your hydrogen. So here carbon, selenium and germanium, that is making a hydrides with these 14 groups. So as we move down the group, the size of the molecule is increased, carbon, selenium and germanium. Similarly for the magnitude of London forces is increases, and they increases its a boiling points. Okay. Similarly for novel gases, as we move down the group, the size of atom increase, that is the size of electron cloud is increases and gets more easily distorted. So London forces is also increases. Okay, for next is your second factor, that is geometry of the molecules. Geometry of the molecule, how to be a factor about the London forces. The shape of molecule has a significant effect on the magnitude of London forces. You have already learned in the organic section what's the meaning for N and what's the meaning for a neo. So here geometry of the molecules, N-pentane and neopentane have the same molecular formula C5H12, but the boiling point of N-pentane is 27 degree higher than that of the neopentane. So here are the two different shapes of these two molecules. N-pentane is a zigzag chain, but the neopentane is a nearly spherical. Okay. So student, this is about the structure of, that is your N-pentane in branch, and that is your, sorry, straight chain, and that is your branch for neopentane. This is your like this neopentane structure, and this is your spherical, this is your zigzag, this your in this way. So overall attraction between the molecule is greater in case of N-pentane because there are more sites of interaction, and the molecules are able to come in contact with the entire length of the molecules. But in case of, there is less contact and hence the less force of attraction. This is a more tendency to attract from other sides of the molecules, but there is a no case because they have full to be compact. So that's why here the n pentane is more boiling point as compared to neopentane. Here is the spherical, that means here surface area is more as compared to this one. That's why n pentane is your more boiling point as compared to the neopentane. So student, this is about the intermolecular forces of attraction. So thank you and have a nice day.